friends, welcome back to the fort. Squeaks is showing me some pictures from his vacation to Iceland. He had a really good time. Oh, where should you visit next? Well, Iceland is pretty chilly. Maybe someplace warmer? Oh, but you wanted to try and visit another island. Warm islands. I've got it. How about Hawaii? Hawaii is one of America's 50 states and is found here in the Pacific Ocean. It's nice and warm there all year long. And Hawaii is made up of lots of smaller islands. Yes, you're right, Squeaks. There are volcanoes in Hawaii. Well, yes, I can see why volcanoes can be scary. Sometimes they can change pretty quickly and suddenly erupt. But we have ways to keep people safe. So safe that we can enjoy how amazing and interesting volcanoes can be. There are 15 volcanoes on Hawaii's 8 biggest islands. 6 of them are active. Active means that they've erupted in the recent past and may erupt again. A volcano erupts when a material like gas, rock, or lava moves from inside the Earth into either the air that surrounds Earth or onto Earth's surface. 4 of Hawaii's active volcanoes are on Hawaii's biggest island. They are Kilauea, Mauna Loa, Hualalai, and Mauna Kea. Good observation, Squeaks. That's a lot of active volcanoes in one area. There are a lot of volcanoes and earthquakes in this area of Earth. There's so many that scientists nicknamed it the Ring of Fire. This map shows the Ring of Fire. It shows where the land is and where there's ocean. And this is the Ring of Fire. It looks like part of a circle. Why are there so many volcanoes? Well, the Earth is made of layers. We need to take a closer look at Earth's crust, its outermost layer. It is made of large, odd-shaped pieces called plates. These plates are always moving. They make up the land we're standing on right now. I know, we can't feel the plates moving because they're moving super slowly. They only move about 1.5 centimeters every year, about the speed a person's toenails grow. Even this very slow movement of these plates is enough to cause big changes on Earth. Earthquakes and volcanoes tend to occur along the edges of these plates. But there's more happening in the Ring of Fire than just around its edges. There's a long chain of islands that runs through the middle of the Ring of Fire. We can see these islands on a map too, and many of them make up Hawaii. How did all of these islands get there? All of the volcanoes in this long chain formed because of the Hawaiian hotspot. A hotspot is a place in Earth's middle layer, the mantle, that is extremely hot. Do you know how on a hot day an ice cube will melt into liquid water? Rock can melt when it gets hot too. The heat from the hotspot rises, which melts the rock above it. This melted rock is called magma. The magma then continues to rise. When some of it pushes its way to the surface, the magma comes out as lava, and that's a volcano. Oh, good observation, Squeaks. Eruptions can be sudden. So how can an island form over a long time? Many volcanoes are like Kilauea, which has been erupting lava slowly and over a long period of time, instead of all at once. The lava from this eruption oozed out of Earth's crust over about 35 years. Then the volcano did erupt more quickly, causing the very shape of the island to change. This is one of the reasons volcanoes are so interesting. Sometimes they can have big eruptions that change things really quickly in one fell swoop, and other times they make changes over a much longer period. For example, one of Hawaii's 6 volcanoes, Kamaehua Kanaloa, is underwater. It would be here on our map. The top of this volcano is about 1,000 meters underwater. This is a clue that it's not as old as Hawaii's other volcanoes. How is it a clue? Well, let's imagine what it would look like if an underwater volcano kept erupting. What would happen to the lava? It would get wet, but it would also cool off. And when lava cools off, it hardens back into rock. And as more and more lava flows out and gets cool, it starts to pile up. What do you think would eventually happen? Oh, that's right, Squeaks! It would peek out of the surface of the ocean. And that's how all of Hawaii formed. The islands of Hawaii formed very slowly because of lava erupting, cooling, and piling up until it reached the surface of the ocean over millions of years. This is a great example of change taking place slowly over a long period of time. Squeaks wants to know how we know it's safe to be near an active volcano. If scientists think that the volcano might erupt, they let everyone who might be affected know, and they will give people instructions on what to do depending on how the volcano is erupting. That might include moving to higher ground away from lava flow, or moving inside to stay safe from ash. If you are in an area around a volcano, it's always a good idea to look for signs like these and to make a plan in case you have to leave the area. But no need to worry, because scientists are always keeping an eye on volcanoes in lots of different ways. For example, they use a tool called a seismograph to detect how the ground is moving. Earthquakes, which are caused by the movements of those big plates, often happen before a volcanic eruption. So if the ground is moving, that could be a sign an eruption might happen soon. Scientists also watch the ground to see if it shifts or bulges up at all. This might mean magma is close to the surface and the volcano might erupt. They even measure the kinds and amounts of gases coming out of the volcano. When they put all of these observations together, they can usually predict when a volcano will erupt and give people plenty of time to get to a safe place. Squeak says now that he knows how volcanoes work, he's really excited to visit Hawaii. Hi there! Welcome back to the fort. My friend Sam the Bat is here today.
Yeah, Squeaks came to visit me in the observatory and told me all about the volcanoes in Hawaii that you guys talked about. And I thought, since we're on the topic, I'd come down and join in. After all, as an astronomer or someone who studies space, I know quite a bit about volcanoes, since scientists have found them on other planets. To that end, I have a science quiz question for you, Jessi.
I love science questions. Okay, go ahead. Ask away.
What is the name of the biggest volcano ever?
That's a really good question, Sam. Mauna Loa in Hawaii is the biggest volcano on Earth. But you asked me the name of the biggest volcano ever. And that would have to be Olympus Mons on Mars.
Drat! I thought I'd trick you with that one.
Ta-da! You'll have to get up pretty early to trick me with a science question. But I am impressed that you know about this giant volcano. What else do you know about it?
Well, like you said, the biggest volcano scientists know about right now isn't on Earth. It's on Mars. Mars is the fourth planet from the sun and our neighbor in the solar system. Olympus Mons is really big. It's 100 times bigger than the biggest volcano on Earth. It's so big that you could fit the main islands of Hawaii inside the base.
Right you are, Sam. It's huge. It's taller than even the tallest of Earth's mountains. Do you know why?
Oh, sure. It's because... All right, you got me. I don't know why. Why is Olympus Mons so much taller than the volcanoes on Earth?
It's a good question to wonder about, Sam, because there's a lot to learn about Earth and Mars when we look for the answer. The reason has partly to do with what's called plate tectonics. When Squeaks and I were talking about volcanoes in Hawaii, we talked about how Earth has layers. We said that if we could take a closer look at Earth's topmost layer, called the crust, we would see that it's made of large, odd-shaped pieces called plates. These plates are always moving, although they move so slowly that we can't even feel it, even though we're standing on top of them. Plate tectonics is the idea that these plates cause lots of changes on Earth, like the formation of mountains, earthquakes, and volcanoes. Sometimes a plate moves over a very hot place in the Earth's middle layer, the mantle. In the mantle, it's so hot that the rock down there is melted, like an ice cube can turn into liquid water, but way hotter. And that melted rock can bubble up from below. As the plate moves over the hot spot, the rock slowly oozes up and leaves a trail. Before, Squeaks and I talked about how that trail of melted rock became the islands of Hawaii. But all that happens because the plates of the Earth are moving. Eventually, the plate moves far enough from the hotspot to drag the volcano away from where the magma can get through the surface. Everything cools down and the volcano stops erupting.
Whoa, that's really interesting. But what does it have to do with Olympus Mons?
Well, like Earth, Mars has layers, and its outermost layer is its crust. Unlike Earth, though, this crust isn't broken up into plates. It's more like one giant piece, and it doesn't move. A long time ago, a hot spot formed under where Olympus Mons is now. But because Mars doesn't have plates that are moving, the melted rock that bubbled up didn't form a trail. All of the molten rock that ever came out of Olympus Mons is piled up around one spot. Since there's no moving plate to drag the volcano away from the hotspot, this volcano has been growing taller for at least 115 million years. That's older than a lot of the dinosaurs, and some scientists say it could be even older.
Super old and super tall? This volcano has everything. Is Olympus Mons still erupting?
Well, we don't actually know. Some scientists think that it is active and might have last erupted about 2 million years ago.
So it might get even bigger? That's awesome.
It would be, considering it's already about 26 kilometers high, which is close to 3 times higher than Earth's highest mountain, Mount Everest.
Whoa, that would be amazing to see. I'd like to take a vacation to Mars to explore Olympus Mons. Can you imagine how great that hike would be?
It would be out of this world. The very top of Olympus Mons pokes all the way through Mars's atmosphere. If you could walk all the way up to its peak, you'd be in outer space.
That settles it. I'm going to go get Squeaks so we can imagine what it would be like to take that vacation to Mars. So let's put the river of lava here. Mm-hmm. And over here, it hits some water.
Okay.
And sends up tons of steam.
Nice. There you go. Oh, hi! Sam and I have been learning about volcanoes, so now we're drawing a model of one erupting. Our model is turning out to be very dramatic, but we still haven't decided what kind of volcano we're making.
What kind? It's a volcano. That means it's a big, pointy, tall mountain that suddenly goes KABOOM! And everyone runs away going, ah, ah, save us from the hot lava, ah!
Well, there's more than one kind of volcano.
Are there even bigger and scarier and more explodey ones?
Oh, yeah. Volcanoes come in all shapes and sizes. Sometimes volcanoes aren't mountains at all. Some are the tall mountains like what we're drawing, but others are small hills. Some volcanoes erupt many times, and some erupt only once. There are tall and pointy volcanoes, flat and wide volcanoes, and even volcanoes underwater.
Underwater volcanoes? Going kaboom and scaring all the fishes?
Well, volcanoes aren't just big, scary monster mountains. The Earth is always changing, building new pieces of itself, and volcanoes are part of that system.
Okay, but do the volcanoes at least all go kaboom?
Some of them do. The thing all volcanoes have in common is a vent, an opening in the Earth's crust. The crust is the top part of the Earth, the part we're standing on right now. Vents open into the lower parts. Sometimes a volcano is just a vent, a fissure or crack in the ground. Or it might be a crater called a caldera that formed when an eruption
Went kaboom!
Yes, went kaboom. And then the ground collapsed to create a big pit. But some volcanoes are giant mountains. Every volcano is unique, but some volcano shapes might look a bit more familiar to us. There are stratovolcanoes, also called composite volcanoes, like Mount Fuji in Japan. They're shaped like cones with a narrow top and a wide bottom.
That's the kind I was thinking of.
When a volcano erupts, hot gases and melted rock from inside the Earth burst out onto the surface. The hot melted rock is called magma when it's under the ground, and after it escapes a vent, it becomes lava. Lava is red hot. It ranges from 700 to 1200 degrees Celsius, and then when it cools, it hardens and becomes a layer of rock. And over hundreds of thousands of years, layers of lava harden to build up a stratovolcano. Then there are shield volcanoes, which are giant but with wide dome-shaped slopes, kind of like a superhero's shield if you look at it from above. Shield volcanoes also get built up by many eruptions over time. Mauna Loa in Hawaii is a shield volcano, and it's the biggest active volcano on Earth.
Active. Does that mean that it does lots of activities, like soccer and ballroom dancing?
Great question, Sam. And not quite. Volcanoes that are active have erupted recently, and scientists think they might erupt again soon. Dormant volcanoes haven't erupted for a long time, but they might erupt again. And extinct volcanoes are probably not going to erupt again.
That's too bad.
Not to worry, we won't run out of active volcanoes. Right now, there are over 1,500 active volcanoes on Earth, and they have all kinds of eruptions. Check out the lava that was spewing out of this 2-mile-long fissure in Grindavik, Iceland. And when Kilauea in Hawaii erupts, sometimes fissures release hot lava that slowly moves across the island. But Kilauea has also erupted into a 300-meter lava fountain.
Holy flying foxes.
Right? And Kilauea may have slow-moving lava, but some volcanoes have erupted very quickly. Almost 2,000 years ago, Mount Vesuvius erupted in Italy, and it shot volcanic material 33 kilometers into the air at a rate of 1.5 million tons per second.
Sweet merciful guano. That's a lot.
Yup. And then there was an avalanche. The nearby towns of Pompeii and Herculaneum were buried so quickly that they were frozen in time, with everything preserved for us to find later, which actually helped archaeologists learn a lot about life in ancient times.
Not so great for them, but pretty neat for us.
Volcanoes can also release ash, a dusty mix of particles from inside the Earth that can be carried long distances by the wind and cause all sorts of trouble. Eyjafjallajökull is a volcano in Iceland that had a super explosive eruption in the spring of 2010.
Eyjafjallajökull?
That's right, Eyjafjallajökull. It released a column of ash 10 kilometers tall. The ash cloud traveled across the Atlantic and over Europe and stopped international flights for a week.
Oh no, imagine not being able to fly.
I know, right? But Eyjafjallajökull wasn't even the most explosive eruption we know of.
Scientists have a measurement for how explosive an eruption is?
They sure do. It's called the VEI, or Volcanic Explosivity Index, and it ranges from 0
Not very splody.
to 8.
Biggest, boomiest kaboom.
Pretty much. And Eyjafjallajökull was only a 2 out of 8.
Only 2? Bummer. Have we ever had an 8?
Well, The biggest eruption in recorded history was a 7 on the VEI scale. Mount Tambora in Indonesia erupted in 1815. The volcanic ash and gases it released into the atmosphere created a cloud the size of Australia. And that cloud blocked the sun and brought down the Earth's temperature around the world. The following year, 1816, was called the year without a summer. Snow fell in the eastern U.S. in July.
Whoa. All these kabooms are cool, but to be honest, hearing about them all, now I'm a little scared. Can volcanoes just blow their top anytime? Is there any way to know when an eruption is going to happen?
Yes, there is. Most volcanoes give us a warning. We can track changes in the Earth, like increases in earthquakes or heat, to study when volcanoes might erupt. And even though they can be a little scary, volcanoes can be helpful sometimes too. Volcanic ash can give nutrients to the soil, which is helpful for plants to grow.
Oh, and when lava hardens, it creates new land and mountains and islands and interesting new places to live, like the lava cooling in the water in our model.
Exactly, Sam. The Earth is always changing and building new versions of itself, sometimes slowly, sometimes all at once, and volcanoes are part of that. Thanks for learning with us today. If you want to have fun with me, Sam, Squeaks, and all of our friends, be sure to subscribe, and we'll see you next time here at the Fort.
Bye.